So PACES stands for Air Pollution in the Arctic, Climate, Environment and Societies. So I'm one of the co-chairs, together with Steve Arnold from the University of Leeds in the UK and Chuck Brock from NOAA in Boulder. And then we have also have a rather numerous steering committee, who you can see the members listed at the bottom of the page, and a website if you want more information. So in fact, PACES was set up as an initiative, or it's sponsored as an initiative under IGAC. So this is the International Global Atmospheric Chemistry Project under Future Earth. And we're also co-sponsored by the International Arctic Science Committee, and in particular the Atmosphere Working Group. So the initiative was spun up following a workshop in Boulder in 2015. And the focus of PACES is really to improve our understanding about remote and local sources of Arctic air pollution, and then also their impacts, and to better quantify their impacts on climate, on deposition, for example, to ecosystems, and also on societies. And there's a paper that was published, so Arnold et al. In 2016, it was published in Elementa. So essentially, PACES is a kind of network. It's an umbrella organization. We try to coordinate and foster research efforts on Arctic air pollution. And our main goal is to try and spin up new efforts to improve the underpinning science, with the longer term aim that this would feed into international assessments, and of course help with policy making. And we also are engaging with many other international initiatives, and I've just listed a couple here. So for example, the Arctic Council working group, AMAP, we have quite a lot of interactions with them through their expert group on short-lived climate forces. We're starting to interact with the WMO GORE Urban Research Meteorology Environment Project. And that's of a particular interest for PACES, for ALPACA, that we're going to hear about, because they're interested in urban development globally, but they're also interested in spinning up further efforts at high latitudes in particular. And I'll come back to that right at the end of my presentation. And then, of course, we have interactions with other more scientifically based initiatives like ISOA. So, my slides, here we go. So this schematic essentially shows what we're interested in PACES. We're very interested in long-range transport of pollution from mid-latitudes. So pollution coming from Asia, from North America and Europe, and how this, in particular, how this impacts climate. There have, of course, in the past been large initiatives looking at this kind of problem before, but there are still many uncertainties related to, for example, aerosol processing, scavenging processes in clouds, and also indirect radiative effects following aerosol cloud interactions. So we're interested in these transport processes. We're interested in the relative contributions of these anthropogenic emissions relative to natural emissions. So, for example, emissions coming from forest fires. And then we're also more recently becoming very interested in local pollution. And this is a rather understudied problem. And in fact, we've come to realize that, there are local pollution sources in the Arctic, for example, from shipping, from oil, emissions coming from oil and gas extraction, which are already having an impact on background atmospheric composition in the Arctic. So they can affect either human health, if there's very high concentrations, or there can be pollution deposition to terrestrial and marine ecosystems. So we have 2 working groups set up so far in PACES, and I'm just going to show a couple of slides for each working group. So the first one, working group 1, aims to improve predictive capability. So this is really tackling this issue of the long-range transport of pollution from mid-latitudes and trying to reduce uncertainties in models. We know that models don't do a very good job in reproducing the spatial and vertical distributions of pollutants such as black carbon, tropospheric ozone, etc. And we certainly have many uncertainties, or treatments of aerosol cloud interactions, for example, are very uncertain in models. And of course, we need to improve these processes if we want to improve climate predictions. So we have this working group, which is being led by Chuck Brock and Steve Arnold, but also Marion Lunt, who's at Cicero in Norway. And we've decided to focus the main effort on trying to spin up a new experiment, looking in particular at pollution transport from Asia into the Arctic. So this is the IMPACT initiative, and I've got a slide about that on the next slide. But we're also trying to link to other, particularly other airborne campaigns. For example, there are airborne campaigns being planned in Germany, also looking at these issues, and perhaps also making use of an aircraft that flies in Russia. So we've just set up an international steering committee related to this working group. So this is the IMPACT experiment. This is being headed up by Chuck Brock. Also Jack is involved a lot in this, trying to spin this up. And a proposal has been submitted to NASA. So the idea here is to, as I said, focus on the transport of pollution from Asia, and specifically China, into the Arctic and into the Alaskan Arctic. As well as having another focus looking at transport across to North America. The aim is to use the DC-8 aircraft and to make multiple samplings through the systems, the frontal systems which transport pollution into the Arctic, particularly during the spring months. So the idea is to have major aircraft campaigns in March and April 2021 and 22, to try and have this kind of Lagrangian, quasi-Lagrangian sampling of air masses as they're being transported into the Arctic, to try and get a better handle on the processes. So here you can see listed all the main PIs, but also there are other US groups, and also importantly we have collaborators in Japan and elsewhere who are going to help us hopefully move ahead with this experiment. And then the other working group that we have set up is the working group 2 on Arctic air pollution societies. So here the focus is on local Arctic pollution. So one of the leads is Kerry Pratt, who's here with us today, and also Julia Schmaler, who's at PSI in Switzerland. So here we're really interested in, as I said, trying to better quantify the local sources such as shipping, emissions from oil and gas extraction, local urban pollution, wood combustion, etc. So this is kind of really, ALPACA is coming out of this working group. And I'm not going to say too much because I know that Kerry and then Bill have further slides on this effort. But I just wanted to mention that, you know, we have, I don't know if it's on Bill's slides, so I was going to mention that there is a paper that's in revision that's been submitted by Schmaler et al. So it's being revised, was submitted to Earth's Future. And this really lays out the kind of the state of play, as it were, with regard to local air pollution emissions and their potential impacts. And of course, the Arctic is a very special place and we have very specific conditions. And one of those particular times and places that we're interested in is the winter time. So that's why we've become interested in looking at Fairbanks as a kind of focus area to study when there are very high levels of pollution. And I mentioned that we're linking to this WMO project, Gourmet, and that's because this project has also links with another project called the Pan-Eurasian Experiment, PEAKS. And there's several researchers in Russia and Scandinavia who are very interested in this problem of urbanization in the Arctic and are very keen to kind of build in an air pollution aspects. So we're following also discussions we've had in ALPACA. We're trying to perhaps spin up a kind of twin city idea, having one study in Fairbanks and another study also in Russia at a later date. So just to finish, I just wanted to show that, I mean, PACES really tries to facilitate some of this building up this scientific effort. We've had several workshops, open science meetings, and we have workshops planned for the next year as well. And we hope to release fairly soon in the autumn an implementation plan so that people can see what we're up to. So with that, I'll leave this slide up if anybody has any questions.
Great, thank you, Kathy. Does anyone have questions on PACES specifically? It's a nice international method for trying to promote studies on air pollution in the Arctic. Are there any questions for Kathy? All right, it's a quiet group, so
I have a quick question for Kathy.
Yes, go ahead.
Hi,
Long, go
Kathy, yeah, do you have a plan for developing cases out of those campaigns for new modeling in the comparison?
Yes, and in fact, I should have probably said as part of the working group 1, so Marianne Lund and a couple of other colleagues are spinning up a kind of pre-campaign modeling effort with the aim to try and use data that's existing to get a better handle on what model uncertainties there are and what are those uncertainties that could be answered by the impact experiment, for example. But then to answer your question more generally, yes, we will certainly, modelling is a very important part of PACES. And we'll certainly be, you know, for example, linking with the AMAP effort, where they're running a whole different series of models. But people are welcome to join, you know, so it's, if you have ideas, then just please get in touch with us.
Yeah, thank you.
Right, I would just say for the NASA proposal for the DC8 part of impact includes several modeling groups, but there is a clear hope that the broader modeling community would take advantage of the data that would come out of it to really assess how those scavenging and aerosol cloud processes that Kathy mentioned are being handled or mishandled in all the models that care to look at the data set.
Yeah, exactly.
And in terms of the observations on data sets, I'm particularly interested in the Arctic local emissions, because those are not right now not in, like, for example, CMIP6 emissions. That probably very important for Arctic local model biases in the Arctic aerosol.
But
No,
I'm sure
exactly.
that Ella and Chinju will say more about that soon.
Yeah.
On the ALPACA plans, right?
Yeah, that's right. And we work with groups, again, through this AMAP expert group. There are groups working on emissions. So there will be new emission data sets available. They produce the Eclipse emissions, which have been widely used. And then they're working on producing new emissions. And that includes local emissions. So, for example, shipping, and also updating the oil and gas extraction emissions as well, for example. But I'm sure there are other emissions that need to be improved.
And so, Kathy, I had just one other question. Are there other plans, other research groups, other nations thinking about joining with this DC8 campaign, or is everybody waiting to see what NASA decides about that proposal?
Well, I mentioned this parallel effort, which hopefully might take place at the same time as Impact. So this is being led by Manfred Wendisch in Leipzig. So there's a large German Arctic program, and as part of that, they have some flights planned with the Halo aircraft to look at transport of pollution between Europe and the Arctic. But there are also other groups in Germany, for example in Mainz, where they're interested to potentially fly a Learjet as part of Impact. And then I know Steve Arnold as well has been discussing with his colleagues in the UK about whether they could join with a B146 aircraft. So yes, there is, on the aircraft side, there's a lot of interest. There's also a lot of interest from people not only in Japan but also in China, So I think we'll see that at the IGAC conference in Japan in September. I'm hoping that there'll be, well, I know that certain key people are coming to that, but I hopefully we'll have a lot of interest there. And also downwind over Canada and Alaska. I think there's interest from the ground-based stations as well. People making measurements, for example, like FTIR, who are interested.
Very good. Thank you, Kathy. I think I personally really appreciate you joining the group today. IARPC is, of course, very US-centric, but I think participation from international groups like PACES offers an opportunity both for the US investigators to connect their activities to a broader international level, as well as some opportunities perhaps for the international groups to gain more exposure to what is going on within the US. So I really appreciate you joining us today to provide this overview. And I think we'll transition to a much more perhaps US-centric piece under PACES, which is the ALPACA, proposed ALPACA effort. So at this point, I think maybe we'll hand it off to Bill. And Bill, if you want to get us started, and I'm not sure whether we'll be able to get Carrie in under her time limit, but why don't you kick us off and we'll see where things are at when we get to her slides.
Sounds good. Can you hear me?
Yes.
Okay, so I'm going to share our slides here, and then I'm hoping that Carrie's still on and we'll be able to tell you a little bit about the context of this work in PACES Working Group 2. So, Carrie, are you here?
Yes, I'm here.
Great.
So Bill will talk more about ALPACA and that project, but ALPACA is coming out of Working Group 2, which Kathy mentioned. You go to the next slide, Bill. And so as Kathy mentioned, this is because we don't know that much about local Arctic air pollution, and especially in the winter time, which makes the Arctic so unique compared to the rest of the world. So most atmospheric studies in the Arctic have focused on Arctic haze season or transport in, and especially summertime aerosol, but rarely ever have there been measurements in local villages and cities in the Arctic, where often there can be very high levels of especially particulate matter, but often it's not even quantified. Bill, can you go to the next one? So the objectives of the working group in general is to conduct interdisciplinary Arctic research and to connect our science really with those local communities and to develop joint research questions with them, working in both the Eastern and Western Arctic, and conducting our research really to benefit the residents and to work with them and thinking about community-based monitoring and increasing all of that. And Working Group 2, of course, through IGAC and IASC is interested in getting early career scientists involved, which is also, I think, evident in Yulia Smalley and I being the Working Group 2 co-chairs. And with that, I will hand it over to Bill, and unfortunately I have to go, but thank you very much for letting me talk.
Great, thank you, Carrie.
Yeah, thanks, Carrie. We were lucky to get a chance to have Carrie present that because she's at a meeting in Telluride, Colorado, in which she's presenting, so she has to go and can't be here for the whole thing. But that's a nice segue that goes between what Kathy was talking about, the broad PACES umbrella, and the more focused Working Group 2 that wants to look at impacts of pollution on societies and specifically local pollution in the Arctic. And so within that, we have a project which we call ALPACA that is trying to understand local pollution in a specific case in Alaska. And that's the case of Fairbanks, Alaska, and particulate pollution during the wintertime. So the acronym ALPACA stands for Alaskan Pollution and Chemical Analysis. And I'm going to tell you about the science that we're interested in and a status report of where the project is at this time. My name is Bill Simpson. I'm here from University of Alaska Fairbanks. I'm an atmospheric chemist by training and live here in Fairbanks and would really like to use that training to help us to get better air quality in Fairbanks. I'm also working with Jingqui Mao, who is both literally next door and virtually next door. So he's online with us to answer questions if we have any. And then I also wanted to recognize the other members of the organizing committee, Carrie Pratt, Julia Schmale, and then Kathy Law, who you just heard from, and Steve Arnold from Leeds. So the 6 of us are putting together this ALPACA effort, and I'm happy to have the chance to tell you about it today. Okay, so specifically going to the situation of Fairbanks air quality. So Fairbanks is a small city in Alaska. We have about 100,000 people, and we have quite bad air in wintertime. We violate the EPA 24-hour PM 2.5 standard. And as of June 2017, we were redesignated by the EPA as a serious non-attainment area, the most serious level. And I think there are something like 4 cities that got redesignated at that time. So you can see Fairbanks air quality on this plot here compared to the current air quality standard, 35 micrograms per cubic meter. And you see Fairbanks is bouncing around but slightly above that level. Additionally, you can see the nearby residential city of North Pole. North Pole has higher pollution than Fairbanks and is within our same non-attainment zone. So we are now violating based upon North Pole air quality data, which you can see is almost twice the federal standard. So we have a bad air quality problem in the wintertime, and we need to figure out ways to remedy the situation. So why do we have this bad problem? We're in the middle of Alaska, right? So the real reasons are that there are strong sources. There's wood smoke that is for house heating. There is oil heating of houses. There's cars and trucks. And a lot of those sources are emitting beneath a strong meteorological inversion. So there's cold air at the surface, warmer air aloft, and that traps pollutants which are emitted at the ground down at ground levels. So you can see in the figure here, which is of Fairbanks, you can see these low stacks are all trapped below the inversion. And then there's a power plant here, which has actually got warm enough outflow to go above the inversion. So you can see there's both a coupling between the meteorology, the inversion conditions, and the pollution which is being injected into this area to lead to high pollutant concentrations in the wintertime. And really the parts that make this happen are cold and dark conditions. Cold leads to a lot of heating, and dark leads to these strong inversion situations. So really the focus of ALPACA is to understand atmospheric pollution under cold and dark conditions. Okay, so what's in those particles? We have been, through EPA efforts, looking at the composition, the speciation of those particles. And here I show an annual cycle of the speciation of the particles in Fairbanks. And you can see the wintertime is the peak season, and the wintertime has largely organic carbon in the particles. Additionally, we have some ammonium and a bunch of sulfate. About a fifth of the mass is sulfate, which is a kind of surprising number. And models can't explain this sulfate. This is more than the models would predict. Additionally, you see a peak in the summertime. These are forest fires, and in the annual average, it looks like a small blip here. But of course, it's episodic, with some summers having extremely bad air quality for a few days during the summertime season. However, the violations in terms of EPA are due to these wintertime events because they're preventable if we were to deal with this problem. Source apportionment studies indicate that these particles are mostly coming from wood smoke. So wood smoke is the biggest source of these particles. And that's certainly the thing we need to get after. But again, there's all this sulfate, and we don't really understand why that's there, and we need to understand that in order to be able to control it. So let's look at another wintertime city. I'm so glad that colleagues like Steve Brown and Joel Thornton and others have started really looking at wintertime air pollution chemistry and trying to understand wintertime pollution. And recently they've been doing studies in Salt Lake City, Utah. So we look at Salt Lake here on the right side and then Fairbanks over on the left. And you see the wintertime peaks are actually very similar in mass concentration, but the composition is completely different. In the wintertime pollution events in Salt Lake City, there's a huge amount of nitrate, not much sulfate, not even that much organic carbon, while Fairbanks has organic carbon and very little nitrate. So these are completely different wintertime compositions, and those indicate that you need different cleanup strategies for these two situations. So what I'm saying is cold and dark conditions lead to different pollution from other cold situations like Salt Lake City, where there is, of course, much more light being at low latitude. So this is kind of Arctic air pollution in Fairbanks as compared to non-Arctic wintertime pollution in, say, Salt Lake City. So with that, we tried to lay out some science questions in order to think about what we'd like to study. So first off, a key question is, what are the sources of these pollution and how do they interact to impact the processing of the pollution? Key in that is that there is this strong boundary layer inversion which traps pollutants that are emitted at the ground and isolates them from background air, which is aloft. So you're both coupling a chemical problem with a mixing problem, overturning of the atmosphere and mixing the pollutants at the ground level with, say, ozone-rich air from aloft. And we want to know how that affects pollutant transformation and deposition of the pollution. A second question that we really want to ask is, what is the role for secondary chemistry in increasing the fine particulate pollution under these cold and dark conditions? So as I mentioned, models can't reproduce the amount of sulfate in the particles. So that begs the question, how is sulfur oxidized under these conditions? Usually we think of sulfur being oxidized by photochemistry or species like hydrogen peroxide, which are the product of photochemistry. So what's the oxidant for sulfur in this environment, and can we understand that? Another question that is important in Fairbanks is that when you have very cold conditions, semi-volatile organic species would be expected to partition more strongly to the particulate phase and could grow the particles. And then there could be chemistry within the particles that could lead to what we would call a non-traditional secondary organic aerosol. So we'd like to ask, is that happening in Fairbanks? Can we understand that? And if that's happening, it might be a pH-dependent process or a phase-dependent liquid versus ice process. So what is the role of aerosol acidity and phase on those secondary processes? Okay, another key set of questions is, we're not in a vacuum here. We're in a place where lots of people live, and we want to take the results that we get and use them to improve our air quality in Fairbanks. So design better strategies for mitigating the pollution problems in Fairbanks. So we have education and outreach questions that get at that. The findings we'll get, I think, will also inform the local people of the problems. We already know that a lot of it is wood smoke, and in order for people to do the right thing with respect to burning wood, not burn on days where it's really bad dispersion conditions, we need to improve the outreach of that information and show that to people so that they'll buy into it and will do the right thing on those bad days. Additionally, we want to do health research here, so connect with the community and try and improve community health. So study the health effects, maybe study toxicology of the particles. Okay, so overall what I've described is a coupled study where there are multiple stakeholders, and these stakeholders, each of which may connect to different agencies, and we need to come together to make an overarching study that will answer these questions and will help out our problem here. So I really see it starting from the Fairbanks community. So we've got the Fairbanks community who has concerns and questions, and that leads to open science questions like I've talked about. Regulators also bring us questions like, how is sulfur oxidized in this environment? Is it secondary? Is it primary? And when we get those answers, we hope to bring them back to the community through outreach, bring them back to regulators through improved source apportionment and understanding the chemistry. Of course, we're doing this because there are health effects of these aerosols. So we want to connect our questions with health impacts and then also be listening to the health community for studies for toxicology or the things like that. And then last of these bullets here, or bubbles, is that there is a connection between what we do in Fairbanks and the local environment around Fairbanks, or more generally for the Arctic, that pollution that's generated in the Arctic will only make it so far and probably has local ecosystem impacts through depositing the pollution in the area around it. So we'd like to study all these parts. In order to get kicked off on this, we had a meeting in mid-May 2018. You can see the website there, and you can subscribe for getting more information at that website. We hosted 44 participants, 11 of whom were international from universities, NOAA, EPA, state and local regulators, many people involved in this study. And you can see the photo there of the people involved. We certainly thank our sponsors who are listed here, and then also folks like EPA who sent people to the meeting, because that really is what makes this effort come together and work well. And we significantly benefited from the PACES affiliation because there were 11 international participants, and there's a lot we can learn from international situations. For instance, other Arctic countries, or additionally high altitude places which have cold weather air pollution chemistry problems, like European alpine cities. So it was a great workshop. The outcome of the workshop is that we are writing a white paper that has the goal of identifying and refining these open science questions, and specifically we're asking them relevant to dark wintertime boundary layer urban pollution chemistry. And that white paper is in process now. We have a lot of the input from the primary writing team, and we're putting that together and refining it. And when it comes out, it will describe what we think are the biggest questions, identify the measurements we have to make to answer those questions, and develop observational strategies. Our timeline is, thankfully, we've done with the workshop. It was great. We're writing the white paper. We hope to have it out late summer, early fall 2018. The white paper will lead to subgroups of people going to funders with questions that are relevant to the mandate of those funders, and writing grant applications that we expect to go in early 2019. And then we hope to have studies occurring in probably a pre-ALPACA phase in winter 2019-2020. And the current plan is for the main campaign to occur in mid-January to February 2021, where we will all be together to study this. So that's our tentative timeline, and please stay tuned to the ALPACA website to be involved in this process. So just to kind of loop it back to Working Group 2 and then back to PACES, many northern cities have similar air quality problems. And so we want to take the results we get and bring them into the context of high latitude cities, Arctic cities, and ask the question of what are the best practices for designing Arctic cities, and can we use this information for other places, maybe not only the Arctic, but also places which are cold and dark for part of the year. So lower latitudes than the Arctic. I think we're going to learn a lot about this cold and dark conditions and chemical processing under those conditions. And then lastly, we hope that we can be involved with the international community to make this project stronger. So overall, where we get to here is we'd really encourage you to be involved. I appreciate this opportunity to tell you about this. We welcome early career scientists to get involved, and we have a lot already involved in the project. And we really want to stress community involvement. So please get involved in this from all different directions. I've got the names and email addresses of the organizing committee there. And with that, I'd be really happy to entertain any questions.
Great, thank you, Bill. I think those are really, really great overview of the growing ALPACA effort. And I'd like to see if anyone has questions specific to the project or to the current process or anything else.
So, Bill, I had a question, and this is Jack, and I was just curious. At the Victoria meeting, it definitely seemed that the working group was very interested in this wintertime chemistry, but also I noticed that Carrie stressed and you stressed community involvement, and that Anne actually chatted earlier on in this about, you know, citizen science in some of the smaller villages across the Arctic. And I'm curious if the PACES working group too is really focusing on these major urban centers in the Arctic exclusively, or whether there are other efforts to sort of branch out to the smaller communities where the people are, rightly or wrongly, also quite concerned about their air quality.
Yeah, we have had involvement at the working group with some people who were representing local villages in Alaska, and it's certainly an air quality problem in villages in Alaska. So we hope to connect with that. So yes, we're very much interested in that. The specific ALPACA field phase that we're talking about here is probably going to be focused on Fairbanks, because we have somewhat of a history of understanding air pollution in Fairbanks, but we hope that findings that we find will be relevant to villages and to other areas around Alaska, and also the health research that would relate to, say, toxicology of wood smoke could be relevant to other places around Alaska. Yeah, so I guess I'd say the focus of the field campaign is probably going to be Fairbanks for partially logistical reasons, but I think the results are going to be very relevant to other smaller places in Alaska.
Bill, maybe I could add on the working group 2 side, the PACES side. I mean, we already have, well, we certainly know of projects going on in Siberia, for example, where we've seen that there are no, well, there's kind of very limited data in Siberia, but we have kind of qualitative evidence, for example, through photos. You can see it's very polluted in Siberia in the winter. And of course, there's a lot of wood burning going on, so in the local villages. So yes, it's a problem, but it's not well quantified at all yet. But I agree with you. The ALPACA study will, you know, help us to understand what's going on.
Right. Well, I was just thinking that it would even circle back, though, to have PACES to what Renee was saying early on, is that, you know, there are the local peoples that are concerned, and would be a great opportunity to reach out to them and try to articulate and answer some of their questions in the smaller villages. But
yeah, sure. I mean, this study in Siberia that I'm mentioning, it's a project with local reindeer herders.
Great.
And it's the reindeer herders who have raised the issue, actually, of pollution.
I had another sort of philosophical question, but Bill, what is the right thing for people to do when it's really cold and there's a strong inversion? All of these people in the dry cabins all across Fairbanks that heat entirely by wood, they just shiver a lot?
No, that's certainly not the right solution. The way that things are going in Fairbanks, there is now a law that has burn curtailments or burn bans that are announced on the worst days, the worst meteorological days, based upon modeling. And if you live in a cabin which doesn't have any other heat source, you go and get a thing called a no ash permit, no other adequate source of heat. And with a no ash permit, you're permitted to burn even on days where it's bad. And there aren't that many people who only have wood stoves as their heat source. And specifically with respect to, I mean, you know, Fairbanks and the Goldstream Valley, the outlying cabins are often outside of the non-attainment area. So they may or may not be within the non-attainment area and may or may not be affected by the curtailments, the burn bans. So nobody wants anyone to freeze. People want people to be warm, but also to be able to breathe healthy air. So I think we in Fairbanks, there's a stakeholder group which is currently working, and both Jinshu and I are members of that stakeholder group, and we're trying to figure out solutions that fit for Fairbanks. And one of them that's being discussed in that group is the idea that maybe electric power could be provided to cabins that have a no ash permit, that don't have other source of heat besides, say, an electric heater, and you could provide electric heat at a reduced rate on the curtailment days. We're now getting these so-called smart power meters that would allow for that. So there are ideas that are trying to provide heat or help with providing heat to people who would have no other alternative than wood on those worst days. So we're working on that, and nobody wants anyone to freeze. It's just we all want to breathe good air too.
Right, but what are the power plants burning to make electricity?
Yeah. So the power plants are coal and oil, and the oil in Fairbanks is relatively high sulfur. So there is a fair amount of sulfur, which certainly is almost certainly the sulfur that is in sulfate in the particles. So yes, you're right that when you switch over to some of these other sources, they're not zero pollution. On the other hand, the modeling studies that have been done in the past indicate that the point sources, most of which have relatively high stacks, mostly emit their pollution above the inversion where the winds are higher, and they seem to disperse before they get down to ground level. That's been done by modeling efforts, and in ALPACA, we want to do that observationally too. One of the things that's going to be neat about ALPACA is we're really having a focus on using new technologies, for instance, unmanned aircraft systems, UAS, which can access the shallow vertical range of the problem in Fairbanks. And I think if you flew a UAS, you would see a pollution layer near the ground. You'd probably then see a relatively clean layer. And then as you kept going up, you'd probably then see the outflow from the power plants. So if we see that, we can show to the community that the power plants aren't having that big an effect on breathing level air quality at the ground. And in that case, we would find that it's better to heat from electricity than to heat from wood.
Very good. Thank you, Bill. Are there other questions?
Yeah, just very briefly to Bill's last point about the injection height. So we recently did a sensitivity study in global model showing that the injection height from industrial pollutions, especially sulfur dioxide, is very sensitive at the ground level. The concentration is very sensitive to the stack heights.
Mm-hmm.
It would be nice to have those information when we developed those local emission data sets.
Yeah, that's great. Very important point. And yeah, please get in contact with me, and I can share with you some of the things that the DEC has been doing in their modeling. And it'd be great to get you involved in this, because that's a really big question for us, is how to deal with that injection height issue, both with respect to particles and with respect to sulfur dioxide.
Yeah, within global community modeling community, this almost like every model has different assumptions for those injection heights.
Yeah. And here it's confusing too, because it both has to do with the stack height and the outflow temperature. A lot of these plumes are pretty hot, so they have a pretty strong plume rise, but then that plume rise depends on the atmosphere into which you're injecting. So it's a pretty complex problem.
Yeah. Thank you.
Okay, maybe time for one last question if there is one, and we're kind of exceeding our hour here, so I don't want to go too much longer, but if there's one other question, we can go ahead and ask that. Okay, if there aren't any further questions, Bill, thank you for presenting this, and and Carrie and Kathy and everyone, I appreciate your presentation.